Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are looking at 5.2, Distance and Midpoint. What will you be learning? Well, by the end of the lesson, you will be able to find the distance, midpoint, and a missing endpoint of a line segment between points on a coordinate plane. Why is this important? Well, so you can understand the distance and the midpoint formula are used to find information about triangles as well as equations of circles. How will you know you've mastered it? Well, when given 2 points, you will be able to determine the distance between those points as well as locate the middle of those 2 points.
All right, let's go ahead and get started. So first, what is a midpoint? Again, a midpoint is the middle point between two endpoints. So because this is our coordinate geometry unit, we are going to be on an x and y axis. So you can see here I'm giving you just quadrant 1 of the coordinate plane. If I go just horizontally, halfway between A and B is going to be this point right here. And then if I go vertically from A and B, our middle is right here, and they are going to meet up right at M. So that would be the midpoint of what would be like a diagonal segment. To calculate the midpoint using ordered pairs, you're going to use x1 and y1 and x2 and y2. So you always have to have two endpoints to calculate a midpoint. Because we're pretty much finding, I think of it like an average. You have 2 points, you find the sum of the 2 points, and then you divide by 2. That would be halfway between them. So vertically, our distance would be whatever y1 and y2 together is, and then you would divide that by 2 to find that halfway point. For x, it would be the same thing. Our x's go horizontally, so you would add them together, and then you would divide by 2 to find the total. So you can see down here, I would like you to add this in this box, please, that x sub m is going to stand for the midpoint. So the x coordinate of our midpoint would be equal to the sum of x1 and x2. So we're going to add them together. And because there are 2 points, we're going to divide that by 2. Y would be found the same way. Our midpoint, so y sub m, is going to be equal to the sum of y1 and y2. So we're going to add them together and then divide the total by 2.
A lot of students get really stuck right here because oftentimes what we will do is we will give you the beginning point and a midpoint and ask you to find the end point. If we ever do that, then what you are going to be doing is you will be substituting in for xm and x1, and it is x2 that you're actually looking for as well as y2. Sometimes we'll ask you to find the midpoint, and when we do that, you'll substitute in for x1 and x2, and you will find xm.
So remember, our x1, y1, x2, y2 are our end points, and x sub m, y sub m is the coordinates of our midpoint. So you have to really look at what information you're given within each problem.
And most importantly, please remember that all of this information that you have here is technically 2 coordinates. So in our example that you see on the screen, you could technically put a comma in between them and put a parenthesis around them because this is a midpoint. You're talking about the x values of a coordinate and you're talking about the y values of a coordinate.
All right, so let's go ahead and practice this. So the first question is saying that we need to find a midpoint of point G and H. So given point G is at -3, 5 and H is at 9, -2, we want to calculate the midpoint. So again, we have 3 spaces where we can plug in or substitute in constants for variables. Knowing that we are looking for a midpoint, that means that our -3, 5 and our 9, 2 are going to get plugged in for our x1, y1, x2, y2. So let's go ahead and do our x's. So -3 and 9 are our x's. So we're going to go ahead and plug that in for our x1, y1. And from here, you're just going to start simplifying. So -3 plus 9 gives us 6. And then the quotient between 6 and 9 would be 3. So we know that the coordinate for our midpoint is at x3. For our y's, we have a coordinate of 5 and -2, so you're going to plug that in for y1, y2. 5 plus -2 is going to be a value of 3, And 3 does not divide by 2 nicely, so we're going to go ahead and leave it as an improper fraction because it cannot be reduced.
Please do not convert this to a decimal. You will find that, especially in geometry and in algebra, sometimes converting to a decimal actually makes things a lot more difficult. So remember, fractions are our friends.
Yes, they are. So we're going to go ahead and write our answer that our midpoint is located at 3, 3 over 2. All right, our next example. So this time if you read what you're given that A is at 2, -3, but then it's saying what are the coordinates of B? And you're given a midpoint of -4, 1. So again, when you're looking at the formula, you have 3 spaces to plug stuff in. Well, you know x sub m this time. You know that one of your x's is at 2, but you don't know the other one. So that's where your variable is going to be this time. So it's going to look something like this. What I would do at this step is, technically speaking, this is sort of like a proportion. You can cross multiply. So to get rid of this divided by 2, you're going to multiply both sides by 2. 2 times -4 is going to give you a -8, and over here these 2's are going to end up canceling out, leaving you with just x plus 2 on the right side. From here you're going to use the subtraction property. Subtract 2 from both sides, giving you an x coordinate of -10. We're going to go through and do the same process for our y's. For our y's, once again, we know one of our y1 and y2's. We don't know the other one. And we know our y sub 1 is is 1. So we're going to go ahead and substitute this in, giving us an equation that looks like this. To get rid of the divided by 2, you're going to multiply both sides by 2. On the left side, we have 2 times 1. On the right side, our 2's are going to cancel out, and you're going to be left with an equation of 2 is equal to y minus 3. You will then use the addition property and add 3 to both sides, giving you a value of -1. So what we just calculated is that point B, or our end point, is located at -10, -1. Okay. So now we're going to go ahead and talk about distance between 2 points, or the length of a segment. So when you're asked to find the length of a segment, we need to measure how long A to B is. Measuring a segment would be similar to taking a tape measure out and measuring it. However, in this unit, we are pretty much going to be on an x and y coordinate plane the entire time. So you're going to be using coordinates to go ahead and do this. Okay, so let's go ahead and talk about how we're going to do this. So first thing I would like to bring to your attention is that when you have a diagonal line, you can always use the grid behind it to actually create vertical and horizontal lines, which ends up making a right triangle. We know that a right triangle, we can use the Pythagorean theorem to solve for missing sides. So if the coordinates are given, you can always create that right triangle, and then we have a squared plus b squared is equal to c squared. If we look at this, our c squared is going to be the hypotenuse, which is segment AB. That's the side you're always going to be looking for. A squared, you can see here I have as our horizontal side, and then B is going to be that vertical side. And hopefully you are visually seeing that right triangle right there. If you can count vertically and horizontally, you can actually just count the lengths of A's and B's, and then that gives you the Pythagorean theorem to calculate what C would actually equal. So what's going to happen when we're doing this, to calculate this distance, it's really going to be the difference between whatever those x coordinates are. So to find A in the Pythagorean theorem, you would subtract the x values. So if A is located at, let me go ahead and write numbers in here so you can see what I mean by this. If A is located at 2, 3, and B is located, we'll say at 5, 7. Well, we know this length right here, this horizontal length, would be 3 because 5 minus 2 is 3. Going up and down to find B, this was the side of B if you look at the right triangle above on your paper, we know that this side would be y2 minus y1. You would subtract your y values. So we know this way we could say is 4 because 7 minus 3 would give me a length of 4. Therefore, remember these three dots mean therefore, c squared is always going to be found by doing a squared plus b squared, which we can substitute in the difference of our x's added to the difference of our y's, both of them being squared. Again, this is, I'm not going to keep this here, but this right here is really just a squared and b squared. C squared is equal to a squared plus b squared. How do you solve for something that is being squared? You have to take the square root of both sides. So if we were to square root c squared, it would become c. If we were to square root the entire right square side, that a squared plus b squared part, well, you can't solve any of that until you know what everything is. So you end up with the square root of the difference of x squared minus x, x2 minus x1 squared added to the difference of y2 minus y1 squared.
So remember, the opposite operation to squaring something is taking the square root of something. Sort of like the opposite to addition is subtraction, opposite to multiplication is division. Please do not confuse something being under the radical with division, because we see all the time students who think that the square root of something or something to the power of 2, that the way you simplify that is by dividing. That is not true. Opposite of squared is a square root.
Which actually leads us into, the point of this was showing the connection between Pythagorean theorem and our distance formula. If you look here, the distance formula, this should look familiar. It's what we found c was equal to in Pythagorean theorem. So go ahead and fill this into the distance formula box. It's exactly what we just unraveled in working out the Pythagorean theorem.
There's a song.
Oh, please sing it.
There's a song. I have a bad voice. But you ready?
This is all on YouTube, my peeps.
Yep. Here we go. You ready? x2 minus x1 squared plus y2 minus y1 squared. Add squares together and take the square root. That's distance formula.
That was beautiful.
Yeah, no.
You're going to win a Grammy for that.
No.
Yeah.
But I think the first time we call on a student in class and they don't know the distance formula, they should have to sing it.
That would be fabulous. Oh my goodness. I would love it. I love it. Okay, so we're just going to now practice working this out. So find the length of segment GH. You're given that G has coordinates of -3, 6, and you're given that H has coordinates of 9, 1. So you're going to, I just wrote the distance formula. It's always nice to write the formula itself. It's going to help you memorize it. We're going to simply take our x1, y1 and our x2, y2, and we are going to substitute it in. It's going to look something like this. We know that 9 is the second x coordinate, so we plug that in for x2. We know that -3 is the first x coordinate, so that went in for x sub 1. Just like in our earlier lesson, when you're plugging this in, I think it was in 5.1 when we talked about this, you're plugging in a negative. Make sure that goes in parentheses because there's already a negative there. For our y's, we know that 1 is our second y value, so we plug that in for y2. And then 6 was our first y value, so we plug that in for y1. And from here, you just start simplifying. So order of operations says we need to solve inside the parentheses first, so this actually becomes a plus. And 9 plus 3 would give me 12, and 1 minus 6 would give me a -5. An important note to add here, please add this to your notes. This step students will mess up all day long. Notice I have parentheses still around my number. That needs to be there, otherwise you are going to get the wrong answer. If you do not have parentheses around this -5, you are going to end up getting a -25 in your calculator, since many of you will plug this into your calculator, and your calculator will give you the right answer for what you're plugging in, but unfortunately you are plugging it in wrong.
Two things to remember here. Number one, your calculator is only as smart as the person using it. So if you are not smart enough to understand that parentheses need to go around this, then unfortunately your calculator is going to give you a wrong answer. So the other thing to remember here is parentheses hug things and kind of keep them together. And when you have something on the outside of the parentheses, it is applying to everything on the inside. So if you think of exponents, exponents only apply to directly what they are touching. So if you have an exponent that is outside a set of parentheses, You want to do the math inside the parentheses and apply the exponent to whatever is inside the hug, so to speak, or inside the parentheses. If you had, by chance, a negative 5 with an exponent of 2, or minus 5 exponent of 2, and there were no parentheses, the final solution to that would be negative 25, because the exponent is only attached to the 5. There's no parentheses holding the negative and the 5 together.
Exactly. So at this step, because the parentheses are always going to be there, the square of your numbers at this step, when you're doing distance formula, will always produce a positive because you're always going to have those parentheses there. So 12 times 12 gives you 144. Negative 5 times negative 5 is going to give you a positive 25. So right here, you should always see two positive numbers. When you add 144 and 25 together, you're going to get 169, and that is a perfect square. You should get that the length of GH is 13.
Now, you should know your perfect squares all the way up to, I tell my students, you should know your perfect squares easily off the top of your head up to 15. And myself being...
I was going to say 25.
Really? Wow. I am somebody who is not exactly overly proficient with my multiplication facts, and I will admit that and tell anyone that is the God's to honest truth. But here's the deal. I do know my perfect squares at least all the way up until 15, 16, 17, 18, 19. I don't know, but I know 20 times 20 is definitely 400.
There you go. All right, so let's go ahead and do this again. This time you're asked to find the difference, or I'm sorry, the distance between the given points A and B. You're given that A is at 8, -7, and you are given that Z has coordinates of 5, 5. If you felt confident on the first example, you can go ahead and pause this and see if you can work through this without our help. This one is not going to work out perfectly, so we'll talk about what we're going to do at the end with that information.
Please make sure that you always start off with the actual distance formula. We should always see that before you start any problem and before you do any substituting. So please make sure that is the very first thing you write down.
Okay, so hopefully you plugged in the points correctly. Our second x value is 8 and our first is 5. Our second y value is -7 and our first is 5. So if you plug it in that order, you should see this. Right here we have 5 minus 8 giving me -3. Right here this would become a plus, so you're going to get 12. Again, those parentheses need to remain there so that when you square them you get positive answers. 3 squared and 12 squared are going to give you 9 plus 144, which is going to be the square root of 153. 153 is not a perfect square. So when you're asked to find the exact distance, that means do not plug it in your calculator and get a decimal answer. That is a rounded approximate answer. So what we should start to see you guys doing is simplifying, similar to how you would simplify a fraction. You wouldn't leave an answer as 2/4, you would reduce that to 1/2. So we're going to do some factoring, prime factoring. Many of you have probably seen this as a factor tree. I do upside down division when I do this. Yep. 153, I think about my prime numbers. Will 2 go into an odd number?
No.
Will 3 go into this? Well, 1 plus 5 is 6, and 6 plus 3 is 9.
So since the sum of the digits is divisible by 9, or sorry, divisible by 3, excuse me, then you know the number is divisible by 3.
So 3 into 15 is 5, and 3 into 3 is 1. Well, can I still use 3? Well, 5 plus 1 is 6, and 3 goes into 6, so I know I can use 3 still. 3 goes into 5 once with a remainder of 2. Bring the 1 down, you get 21, and 3 goes into 21, we know 7 times. 7 is a prime number, so I am done at that point. Because we're dealing with square roots, you're looking for numbers that multiply to themselves. Well, I have a pair of 3's right here. So 3 can go ahead and leave the radical, while 17 is all by itself, so it needs to stay in the radical. If you ever take multiple numbers out, you will this is all multiplication. No addition is happening in this problem at all. So if you take out multiple numbers or leave in multiple numbers, you will multiply them together. And that is the conclusion of lesson 5.2. Hopefully you guys feel good about midpoint formula and distance formula. If you guys need extra assistance with simplifying radicals, we would be happy to assist that to you. For you, if you have questions, please reach out to us via remind or email.
Hey, Mrs. Weichel.
Yes, Mrs. Ness.
God, I hate using Pythagorean theorem.
You do? Why?
Yeah, it's such a hypotenuse nuisance.
Oh, man. Thanks for joining us. We'll see you in 5.3.